Hi everybody. As many of you will be in the same boat, I wanted a bandsaw sharpener for my Woodland Mills sawmill, but I wasn't prepared to pay what Woodland Mills wanted to charge for one. So I built one in accordance with the kind of basic pattern that you can find for many such devices like this. I'll put a link in the comments to the video of the guy that did the clearest explanation and the one that's closest to what I copied here. I used some slightly different components than he did, just a matter of convenience when I could find. First of all, I used this Vevor chainsaw sharpener and just basically took the rest of it apart. I already have a chainsaw sharpener, but I wasn't prepared to just take it and have to swap parts of it back on and off when I wanted to sharpen chainsaw chains. So I just bought this one. It was about $65, I think, including delivery. Super cheap. Comes with a few stones. Put the thickest stone on it that it came with, which I think is about 3/16 of an inch wide. And I made a wooden pivot block, which you can see back here, to support it. Very simple. And that allows me to adjust the angle of attack of the blade relative to the teeth. I used the up and down stop that it came with, and I have that riding just on a piece of flat bar. That flat bar, as you can see, it took a few iterations to get it to the right spacing. But anyway, the idea of this flat bar is that the flat bar at this end has a bearing, as you can see, and it rides on the cam. The cam is driven by the motor, and then this adjustment arm here, which is made in a pattern very similar to ones that other people have made, allows you to adjust how far the tooth advances relative to the blade position. That pivot that drives the blade advancement here, it's just set 3/4 of an inch from the center of the wheel, of the cam wheel, and it really kind of doesn't matter. It basically, what happens is, as the thing advances, it acts as an escapement. So it actually goes back more than the distance of one tooth, and then shoves the tooth forward to its maximum travel, and then it pulls back and again goes into the next gullet. And so you'll be able to see that when I turn it on here. See, it basically advances, and then it pulls back more than one tooth, but it always only advances one tooth at a time. And by setting this adjustment back and forth, you can adjust where the tooth ends up. The motor that's driving this thing is one of these little gear motors. You can buy them on Amazon, you can buy them on AliExpress. I actually had one laying around that was 90 RPM, and I found that it spun too fast. And the 30 RPM one that I have there now, it spins at just about the right speed with that little speed controller that you can see that I've installed. It's running on 12 volts with a little speed controller. But the trouble is that when you spin it at slower speeds, unless you have a really good blade guide arrangement set up that keeps everything really low friction, the motor doesn't have quite enough guts when it's turned down to low speed. So if I had to do it again, I think if I could find one that was 15 RPM, I would probably use that instead. The blade guide here that holds the blade in position, that's just the two pieces that came off of the Vevor chainsaw sharpener, and I just use them because they're perfect. And I have a welder, so I welded them to a piece of plate just to fasten it down to this piece of plywood here. You can see also I didn't plan very well, so I had to add a piece of plywood to my piece of plywood in order to make this long enough. What's important here, and the reason that this push arm and hence the flat bar that rides on the cam. The reason they're so long is that you don't want this push arm to be on too steep an angle, because then it's working at too little mechanical advantage, and it just has a hard time moving that big blade around in a circle. So getting it lower was necessary. As far as how, and that meant making it longer. As far as how to profile your cam, you can see I didn't do a very good job of it. I kind of screwed it up, and I had to add some tape to one section in order to give me back some thickness. Now, eventually I could make a replacement for this, make a bunch of them, and then grind them or sand them until I get them exactly right. But it really kind of doesn't matter. All you're trying to do is to get the blade to or the grinder to grind the inside of the tooth and sharpen it, and then grind a little bit of the gullet to remove any micro cracks that are in there. And then I like the grinder to actually take just the weeest little lick off the top of the tooth to make sure that all the teeth are the same height. And when you're done grinding, and I think that would be helpful in order to make sure that the blade cuts consistently. I don't know that for sure. It's probably not absolutely necessary, but it also does a much better job of sharpening. It deburrs everything, cleans everything up. As far as other modifications, I bought this little drive flange here. The dimensions of these JGY 370 gear motors that you can use here, they have a 6mm diameter shaft, and then they have bolt holes that are threaded for 3mm standard thread bolts. And I can't find 3mm bolts around anywhere, so I had to actually buy some. The other thing is that this little drive flange, it comes with two tiny little set screws, and they are way inadequate for the job, even with Loctite on them. So what I did is I drilled out, and I don't know if I can get this to focus for you, yeah. I drilled out the flange for a 1032 set screw, and that one engages with the flat on the shaft, and that makes it a lot more solid and less likely to wiggle loose, because obviously there's a lot of oscillatory up and down motion, a lot of rattling going on here when this thing runs, and as a consequence it can work those set screws loose. So that 1032 set screw is in there really tight, and I've got some Loctite on it, and I think that'll hold pretty solidly. Here's just a close-up of how this adjustment mechanism is done. There's the threaded rod, it's double nutted at one end. There's a piece of 1/2 inch thick HDPE plastic that acts as the pivot arm, and it has a hole drilled and tapped through it at 1/4-20, and then a big long chunk of all 1/4-20 all thread with just a wing nut and a second nut on it for adjustment. And you just basically adjust that back and forth until you get the grinder lining up, taking just precisely the right amount of the back of the tooth off. Anyway, the next little bit of the video I'll show it operating, actually grinding some teeth on this bandsaw blade, and hopefully the next video will be of my tooth setter, which again is based on a design that somebody put on YouTube.